Hello there, students. Today, we're going to learn about the Biot-Savart equation. The Biot-Savart equation comes from the fact that a charged particle, moving with some velocity, creates a magnetic flux density field, or B field, in all space. The equation looks like this. In SI units, the Biot-Savart equation has a few constants. Mu naught over 4 pi. Mu naught is the permeability of free space, or vacuum permeability. We also use the unit of amperes, or just amps, for current. This Biot-Savart equation is good if we have a single moving particle, but in most practical cases we have an entire current-carrying wire. As an example, if you have a reasonable current of say 10 amps, that would be about 10 to the 20th power electrons passing through a wire per second. That's way more than a single moving particle. In most cases, we'll be working with a long, thin wire carrying some current. We can modify the Biot-Savart equation to reflect this by rewriting the charge times velocity term, keeping the same units and the vector nature intact. Charge has units of coulombs, and velocity has units of meters per second. Velocity is also a vector, which is pointing in the direction of motion of the particle. Current, I, has units of coulombs per second, or amps, and length, L, has units of meters. If we let this length become a vector, also pointing in the direction of motion, which in this case also means the direction along the length of the wire, then we have all the same units and a vector, but now instead of charge times velocity, we have current times length. This equation, however, implies that the entire length of the wire is in the same direction, and that each piece of the wire is exactly the same distance from the single point in space where we want to calculate this B field. This distance is what is measured by the vector r in the equation. To be more general, we usually look at tiny pieces of the wire, an infinitesimal length dl, which has a current I passing through it, thus generating a tiny infinitesimal B field dB. This tiny infinitesimal field equation looks like this. To get the entire B field produced by this wire, we need to add up all these tiny infinitesimal pieces together by integrating. Therefore, this is the form of the Biot-Savart equation we generally need to solve when working on physics problems. In theory, the Biot-Savart equation can be used to solve the B field at any location in space due to any conceivable orientation of current-carrying wires or moving charged particles. In reality, though, performing this cross product and integration can often be literally impossible to solve analytically. So, without going to numerical solution methods for this integration, we're limited in the types of problems we can actually use this equation to solve. In the next video, we'll use this equation to solve for the B field of a number of current wire configurations. Until then, thanks for watching and learning about physics. If you have any questions or want to see a specific topic, leave a comment below or head over to my Facebook page in the video description.